Hi, everybody. We got a request to make a video for uh, exercise section 2.4, number 5. And here we go. Find 10 values of x such that phi of x is equal to 24. Now, I'm not going to do this, I'm not going to go through all 10, but I'm going to do a few and give you an idea how to work this kind of problem. So let's get rid of this. Okay, so here we go. 2.4, number 5. Find 10 values of x such that phi of x equals 24. So we know that phi of x equals 24. That we know. We also know the general formula that phi of AB is equal to phi of A times phi of B if A and B are relatively prime. That means this means if the greatest common factor, or whatever you want to say, greatest common factor of A and B is 1, which means that they're relatively prime. So let's pick an A and B. Now, I'm not saying wait, something here is askew. Right. So let's try to find an A and a B. Let's try to find an A where phi of A is 12, and we'll try to find a B where phi of B is 2. And of course, we're going to want that A and B be relatively prime. So let's try to find an A and B. Let me write this down. Try to find an A and B. I guess A and B, I don't know how to say it. Where phi of A is equal to 12 and phi of B is equal to 2, and A and B are relatively prime. Well, to get phi of A equal 12, we know that 12 plus 1 is 13. All right, 13 is a prime number. So we know that phi of any prime number is p minus 1. So phi of 13 is equal to 12. So let's let A equal 13. Let's try that. Now we need to find a number where who has a phi of 2. Well, there aren't that many numbers that have a phi of 2, but phi of 3, because that's p minus 1, is 2. Now 13 and 3 are relatively prime, so that's good, which means x equals 39, meaning 13 times 3. That's going to be a solution. If I take phi, in other words, phi of 39 is going to equal 24. But hold on. If once we know that phi of 13 equals 12, 4 also has a phi of 2, and 12 times 2 is 24, and 13 and 4 are relatively prime, so let's try that. Well, that means that works. That's all I need. So as long as I have all that, then I get 13 times 4 is 52. That's also a solution, i.e. Phi of 50, or phi of 52 equals 24. And I know that phi of 13, again, letting phi of 13 equal 12, I could take another example where phi of a number whose phi is equal to 2, and phi of 6 is equal to 2, because the only numbers that are relatively prime to 6 are 1 and 5, numbers less than 6. So that's good. And now I have, which means, and 13 and 6 are, again, relatively prime. So 13 times 6, which is 78, is going to be also a solution. In other words, phi of 78 is isn't that interesting? Yeah. So there you go. So these are, and you could just try different combinations. You basically have to just try different combinations of A, B, where they multiply out to not that A, B multiply out to 24, but phi of A times phi of B has to equal 24. That's really what we're looking for. So I guess I'm just going to say need to find an A and B where Eh, so it's not that you need A times AB to equal 24. It's that you need phi of A times phi of B to equal 24. So we just and one way we did it is letting this. Now we could try other things. We could let phi of A equal 6 and phi of B equal 4. We could, or maybe we could find other examples. Or I could break them to three numbers. Maybe I could make it, I don't know how to make it three numbers there. Maybe we could make maybe we could break into three numbers. I don't know. What phi of A is three, and phi of B is four, and phi of C is two, or something. I don't know. I mean, be creative here. This is the idea, and you can start, using this methodology to find all of your values. Anyway, I'm going to. That's the end. That's the end of this recording, and we'll see you next time.